Today we're going to set up a basic weather station and send it to a server endpoint. So I'm going to start by using an ESP32S3. This is from Seed Studio. So we'll kind of go forward and I'll start by setting this up. This device is about the size of a dime. It has an external antenna that goes with it. They're extremely small and compact. So we'll get this up and running here real quick. First thing we need to do is download and install the Arduino software. I'm on a Mac, so I'm downloading the Mac Intel version. And I can just click on just download, and it will now go through and download this for me. Once I have this downloaded, I can go through and install it. So we have the instructions to actually install it after we download it. And for the Mac, it's extremely simple. I'm just going to open up the download image. So I open up the download image. I will copy that into my applications folder. And now I'm all set up. I will take that icon in the application folder. I'm going to open Finder and go to Applications. So I'll open up my Applications folder. I'll find the Arduino IDE. I will actually copy that down to my status bar so I can quickly launch that. But let me open it up here. It'll ask me a question maybe about permissions to trust the creator, and I'll click OK. It'll then open up the IDE. After the IDE is started, I need to go through and create a board manager. So it's going through and doing some updates right now. I'll let these updates complete. So we're going to install this board manager, and this should give us access to the boards. Okay, now we're going to go to Tools and select a board. We're going to go to Board Manager, and here we're going to type our ESP32, and this is from Espresif. So we're going to click Update. And we can see that it's updating the new ESP32 boards. It'll be done here in a minute or so. Okay, there we go. We've installed the driver. And now we can actually go through and select our board. And I'm going to select the serial USB. Now down the bottom I can see it's connected. Great. So we're making some pretty good progress here. We found the board and we connected to it. So let's see if we can start with a new sketch, and hopefully we can find a simple blinking sketch. So I'm going to go down to the samples, and hopefully I'll find a blink. I'm going to go into Basics and Blink. We'll open up this sketch, and let's try to run them. It's compiling. After it compiles, it will upload it. Okay, it's done uploading. It should be running. Okay, I can see it writes to the device. And I can see the LED flashing. All right, great progress. So now that we have the ESP32S3 configured, we can take the next step and start writing a little bit more interesting applications for it. Okay, now that we have the ESP32S3 working and we have our basic blink working, let's take it to the next level and let's actually do a network connection, since ultimately we're going to want to send the weather information to a network endpoint. I'm going to go through and create a new sketch. I will close the old sketch, move the new sketch into that window, and I'm going to initially give this a name. I'm going to call it Network 1. Okay, this is still set up for a device of ESP32S3, and we need to do a couple things to use the networking. First thing we need to do is we need to include the Wi-Fi library. So we're going to include the .h in here. I need to add some information for my SSID and my password. I have a SAD Wi-Fi link, and that's what I call my network. And my password is as simple as SAD Wi-Fi link, and it's my local 24G network. In my setup, I'm going to put a little bit of code in here. And the first thing I'm going to do is I'm going to wait 10 seconds before I do anything. And now that I've waited 10 seconds, so notice I'm using delay, not sleep. After I've waited 10 seconds, I'm going to set the serial port up because I want to see some output. I'm going to set that to 115, 200 for the baud rate, and we'll go over that in a minute. Then I'm going to wait for the serial port to become active, and so I'll just be in a loop, well, not serial. This is probably more important on older devices. New devices probably don't need this as much. And now print out a small message that says device startup. Now I'm going to call the begin method on the Wi-Fi. And what that does is I send in the SSID and password, which I defined up here. Sometimes I'll store that in volatile storage. For this application, I'm just putting in a line into a variable. Notice the variable is a constant because it doesn't change. Okay, now I will send a print statement connecting Wi-Fi ... Notice this does not have a line feed. And then I have a loop here that I'm going to spin in while I wait for the Wi-Fi connection. And this is while not connected. Okay, and then I'm going to print out a dot. After I'm connected, I'm going to print out a couple bits of information. And I want to print out a line that says I am connected to the Wi-Fi with a line feed. Then we're going to say my IP address, and I'm going to print out my local IP. Okay, so that's pretty much all we have to do in the setup. We're going to do a little bit in the loop as well. And in the loop, what I'm going to do is check to see if the Wi-Fi is connected. If the Wi-Fi is connected, I'm going to do something. Otherwise, if it's not connected, I'm going to do something else. So if it's not connected, I'm going to simply print out that it's not connected. And I'm going to wait 10 seconds. Excuse me. I'm going to print out that it's not connected. And I'm going to wait 1 second. But if it is connected, then I'm going to say doing work and wait 5 seconds. Okay, so in our main loop, we have this process right now. And let's fire this up and see if it works. So I'm going to hit the upload button. This will go through and compile the sketch. And now it's uploading the file to the device. Once the upload is completed, it will restart the device. Okay, the device has been restarted. If you remember, we have this delay of 10 seconds in here to wait for the serial monitor to connect. We have a little button over here called the serial monitor. Okay, I'm going to click this button to open the serial monitor. And remember, we waited 10 seconds for the serial monitor to connect. And then we print out device startup, which we see that, connecting to Wi-Fi, connected to Wi-Fi, our IP address 10.10.10.50, and then we're in this loop, do work. And if I open a terminal on my Mac, I can now ping 10.10.10.50, which will be the board. There we go. Okay, this looks good. I think we have our basic networking going, and so we can start taking the next step. So the next thing we need is an API endpoint. So let's create one of those in Python real quick. So I created a directory called WeatherPy, and in that directory, I'm going to create a Python virtual environment. I do that with pyenv python 3 space -m space venv space venv. And then I will activate this. Activation is a little bit different on Windows. And now that I have that, I'm going to make this a Flask API. So I need to install Flask into my virtual environment. And I can do that with pip install Flask. That'll go through and install this here. I should be set up. The next thing I need is a file called app.py. And that's where the code is going to be. I have VS Code, so I will do code space dot to open up this file. Okay, so this is the file. And in here, the first thing I need to do is import Flask. And I'm going to import Flask, request, and JSONV. I'm going to create an app based on the Flask. And then I'm going to start a server based off the default host 0.0.0.0, so all active hosts. Debug true on port 8080. And I'm doing this setting up of dunder name equals dunder main. Then I'm going to set it up. So if this is the only application in here. Okay, so I'm going to create a post request. And in this post, I'm going to have a prefix for my API. So all my APIs are going to be API v1 prefix. So it's going to be API/v1. So let's work on the weather post to start with. So we're going to do a post route. And in there, we're going to create this using some weather data. So it's going to be post weather. And I'm going to get the data from the request JSON. Remember, we're imported request, part of the Flask. So I'm getting the device ID, the temp F, and the temp C. And I'm going to do something with that. For now, let's just print it out. And returning a code 201 instead of a 200. That means created. So let's run this and make sure it works. So we'll do Python 3 app.py. Yep, it is running. And then I'm going to use a program called Postman to see if we can create this data. Okay, so I'm going to create this. And I'll notice on my logs over here, it says received weather, device 1, temp 70. All right, great. So the next thing we might want to do is put this information into a collection. Eventually, we might have a database, and I probably will add a Mongo database at some point. But let's just add a collection right now to store it in, so it'll be kept in memory. And we can do that very simply by taking the data that we've sent in and appending it to this collection I just created here. Okay, and now that we're storing something, it might be nice to get some data back. So I'll do a get endpoint as well. And the idea of the get endpoint is you'll pass in the device ID, and then you'll get a filter on the device ID. Right now, I'll just return everything in the collected temps for now. We'll add filtering later. Okay, so that has been restarted, and we don't have any data in the collection. If we run our get now, the collection is empty. If I go through and do our post, we added one for 7 degrees, and let's add one for 75 degrees, 21C. So now if we do our get, we see we have a temp F at 70, a temp F at 75, so we're getting multiple things in there. Okay, so that's the basis of our endpoint. And we'll keep the endpoint in there, and we'll add a date and some other properties later. So eventually we could use this to do some notifications. Hey, my server room is too hot, or humidity's too high, or maybe just the outside temperature is too hot. All right, so now that we have that, we can move forward and we can start modifying our board to actually collect some data and send it to the server. So then first thing we'll do is we'll send some sample data to the server to make sure the API is working. Okay, let's see if we can get this to send some data to our new API endpoint. I'm going to go through and copy this sketch. I'm going to create a new sketch. I'll copy this old sketch into it. We'll close the old sketch. I'm going to call this sketch Network Dummy. So it will just have a dummy piece of data. And I need to go through and add a library. One of the libraries I need to add in here is going to be the Arduino JSON library. So I search for the JSON, and I need to install that. Okay, great. That should be installed now. So now we can use this library. Okay, so we're loading this library in now into the project. And now that we have that, we can actually go through and start creating some of the information for our JSON output. So I'm going to create a holder for our JSON output. I'm going to make it 128 bytes. Should be plenty big for anything we need. And then in our actual output, in our loop where we say do work, theoretically, I'm going to get the temp and humidity, and then I'm going to send to server. So I'm going to get a float for temp C, and I will get a float for temp F, and I'll get a float for the humidity. Okay, and then I want to send that data to the server. Now we're going to send that using the HTTP client. So we're going to create a JSON document here. Say const size t capacity JSON object size. And we're going to want to send 4 items in here. We also have, I'll put it at the top, we have our device ID. I'm just going to say 1 for now, and it's a string. So we have 4 items that we want to send. Okay, and then we can set up our static JSON document. Our capacity, it means 4 elements. This is going to be our doc. So we create a JSON object, and that's going to be a doc.toJSON object. And then we're going to say object sub device ID equals device ID. Then we have 3 more fields that we want to set in here. That's going to be temp C, temp F, and humidity. So now we've set the values in our JSON object. We need to create an HTTP client. And then we need to set up the client begin with the URL we're going to be sending this to. And this is going to be our URL for the server. We need to know the actual IP address of the server. So let's go back to our terminal over here. And it's not just 127.0.0.1. I'm going to run ifconfig to see what my actual IP address is. And it should be 10 dot something. Right here, 10.10.10.39. So my connection is going to be http://that:8080/API/v1/weather. Okay, and let's also go back to Postman and make sure this URL works to make sure we have the right IP address. And it does. So let's go back over here. I will send some data again just to verify. Yep. Okay, so that's great. We have the IP address correct. So for the client begin, we have the IP address, and we should be ready to go there. We need to add a header. So client add header, content type, application/JSON, so the server on the other end knows what kind of content it is. So now that we have our JSON content ready to be sent out, let's take a break here and let's just print out the JSON. So we're going to serialize it, serialize JSON, the doc to the JSON output. So let's hit this. Let's try serial.println And let's print the JSON output. All right, we'll go ahead and compile this and try running this on the board. So we're waiting for this to compile here real quick. It's uploading it to the board. When completed, it will restart the board. Okay, let's go back to the serial monitor. In a minute, we should see the activity, and we see the data, and it is in the correct JSON format that we expect. Okay, so we have that part done. Next step is to move it into, sending it into the actual client. So let's go back. So we have set up here HTTP client. I'm going to comment out the output to the serial port. Create the client. I'm going to do a begin. We're adding a header. Now we need to send the data itself. So now we can add in here the actual post, and we'll say int HTTP code client post, a string of the JSON output. Remember, the JSON output is a character array, and this allows us to actually send it here. And what we're going to look for is HTTP code, if greater than 0. We expect it to be a 201, so we're going to serial print response code serial print line, and then we'll see HTTP code. All right, and now after we're done with this, we need to clean up by saying client end. We can also get the response string from the client get, which should get the response, if anything. Let's call this the payload for the response, and we'll get it as a string. Okay, and if we get something that's a string, again, we want to print out the values. So we'll print out response string as a payload. Okay, let's give this a shot and let's see what happens. Okay, we're compiling the sketch. We also need to include HTTP client. All right, now let's compile this and see if this resolved the problem. All right, let's fix that, and that should be an uppercase post. Okay, compiled and it's uploading to the board. Once completed, it should reset and restart the board. So we can go to the serial monitor, and we have the 10-second delay still. Return with a 404. All right, let's try to verify this again. http://10.10.10.10/API/v2/weather. Let's add this to a string so that we can print this out. Okay, hopefully we'll be printing out the URL now. Let's compile this, upload it, and run it. All right, let's verify this IP address with Postman. And it comes back with 404, so I have something wrong here. We have an error here, and I put in V2. It's actually V1. All right, let's give this guy a try again. See if it works now. All right, let's open the serial monitor and see what we get. We got an error code 500. So Python had an error. It was looking for temp C. And I made a typo. And I made it an O instead of a P. All right, let's fix that. Run this again. All right, we're uploaded. And let's see what happens. Waiting for the serial monitor to start. Looks like we got a 201 success response. Now let's go see what we have on the weather side. Return 1, 75 degrees. So what we're seeing here is every 5 seconds we're getting data. All right, so now we have the basic environment, sending data, sending mock data. We just need to wire it up to a DHT11 to actually collect real temperature. All right, moving on. So we're going to go through and integrate the DT11 device. So I'm going to wire it up to pin 10 on the board. So I'm going to take this sketch and copy it. I'm going to create a new sketch. I'm going to paste this information into the new sketch. I'm going to call this new sketch Network Real. Okay, and what we're going to do here is we're going to start adding the DHT sensor library. So we're going to go into library. We're going to search for DHT sensor library. How about DHT by itself? Maybe DHT11. Looks like we have quite a few libraries to pick from. I'm going to go with the DHT sensor library from Adafruit. And apparently it wants me to install some other libraries. I'll go ahead and select that. Okay, they're now installed. And let's see if I can now compile. Good sign. Looks like it found the include file. Okay, we're going to close the library now, and we're going to set up the device. We've included this now. And I'm going to set up the device here. And in our setup itself, we're going to also configure the DHT. And now on the application, we can actually start using it. You have to make sure we have this DHT. I made a typo a moment ago. And to actually use it, We can change our variables. Rather than using static values, we can get the value from the actual device. And we will do that with the read temperature. If we use the read temperature passing true, this should return the value in Fahrenheit. By default, it's Celsius, and then read humidity. Okay, so let's see how this works. See if it compiles. And let's try to upload. Well, I don't see any value being sent for temp F. Let's look at the code here. And let's actually print it out to the serial board what we're sending. It appears I may have the wrong pin configured. Let me try pin 9 and see if that resolves the issue. Let's restart it and reload it and see the values in. Now we're getting temperatures in the serial monitor. I think I had the wrong pin. Now we're getting temperatures through the API. Okay, so the question is, are these correct? We have the humidity right here. I will breathe on it, which should significantly increase the humidity. There we go. Humidity is 49 now. Now 68. So we are getting humidity. We're getting an increase in temperature as well. We could go back on our Python code and I could print out the temperature and humidity. I shall do that. Temperature in Celsius, temperature in Fahrenheit. There we go. Okay, that gets restarted, and the data coming in now will show the temperature, Celsius, Fahrenheit, humidity. I'll breathe on it again, and the humidity should go up. And we can see it does. So now we can see that the sensor is working and the API is working. I have added the antenna to the device, and I'll do a short video here of the device connected while it's gathering data and how I wired it up. I soldered 3 connectors on here, one to ground, one to 3.3 volts, one to the GPIO 9 pin, and then the other 3 I connected to the DHT11 device. Let me add a short video to this. Okay, here's a final product. I soldered some wires to it, to the DHT11. I also plugged in the Wi-Fi BLE antenna onto the ESP32S3 device. This device is a USB-C, so it requires a USB-C connector to power it. You can also run this off batteries. It's very energy efficient. This device also has a sense shield, so you can add a small camera to it. A very powerful device. It's amazing what Espresif has done on a lot of their chipsets. This is a Seed Studio board. I think the price of it was about $15. The DHT was about $3. The antenna maybe $2. So for under $30, I have a nice temperature monitoring device, and I can call an API with it. This API I'm hosting with Python, and I will probably add a captive portal to this so it can be configured with an IP address and SSID through a phone. That way I can use this at home. I will have it connect up to my backend service. I have a weather monitoring system that I'm building called WeatherGnome, and it'll have an API to send this type of data to, and also have some sort of notifications, probably an iPhone app, an Android app, maybe some text notifications, we'll see. Anyway, this is a nice little project. Hope you enjoyed it. Let me know if you'd like to see this type of project. I do a lot of stuff on Udemy for IoT. It's been a while since I've done any IoT, but this is a new device I thought would be very interesting to dive into. I will be doing some AI IoT in the future as well for some of the smaller LLM models. All right, hope you enjoyed it. Please like and subscribe. Thanks.